Today we look at the inverse of the parabola. Now these 4 steps are not specifically stated on your notes, so if you want to jot it down, you can. It is how to draw the inverse of a parabola. The first thing that you need to do is find the turning point, but only the x value of the turning point, because that is important in order to draw your inverse. Only the x value of the turning point. How do you get a turning point? The new method, get the first derivative, set it to 0, and then you solve x. The next step is to determine the inverse. Now, if I give you a function with a function named f, you first have to rewrite the fx as y, and then you swap x and y. Then you draw your parabola, but what is important is the middle point of your table is the x value of the turning point, not 0. It's the x value that you just worked out there, and then you go 2 to the left and 2 to the right. Determine your y values, and then you have f. But the inverse is you swap x and y. So for the inverse, y will be those values and x will be these values. So you don't have to redraw a new table. You can just flip these. And then the fourth question that I can ask you is a new one. You will see that the parabola's inverse is not a function. And the question will be, restrict the domain of the function, the old parabola, so that the inverse is a function. Okay, this will make sense when we do an example.
Then I have a question. To get the turning point, can you also use negative x equals negative b over a?
2a. 2a. Okay, can I carry on? Our first example is the mother function of the parabola x squared. Okay, the question is, restrict the domain of f so that the inverse is a function. In order to get there, I'm going to do all the steps fully. First, we get the turning point's x value. Get the first derivative, so that will be 2x equals to 0. And then get x alone by dividing by 2. So my x value of the turning point in this case is 0. Then we have to get the inverse. I named this function fx, but I can't use an fx in the inverse. I first need to rewrite this fx as y. So y equals x squared. And then to get the inverse, now I can swap the x and the y's. And then I need to get y alone. So I get the square root on both sides. But a square root answer is also always positive or negative. Now what you need to know is this is not a function. So I can't name it f minus 1. Although the function's name is f, the inverse is not a function, so I can't call this f minus 1. So now I'm going to show you a trick. Okay, let's draw both the normal parabola and the inverse on the same axis. So you use the turning point's x as the middle value of your table. Go 2 to the left, 2 to the right, and then you get your y values. Pardon? You take the turning point's x value, put that in the middle of the table, and then go 2 to the left and 2 to the right. Then you get your y values. Now for the inverse, instead of redrawing it like on your notes, you can just write to the left of the table, this is my inverse y and my inverse x. So you only have to draw the table once. Okay, now to get to the drawing. I drew fx, the normal parabola in blue, and when I dotted or plotted the inverse coordinates, it looks like this, the pink one. But it's not a function. Why? Why is the pink one not a function? The vertical line test, yes, it cuts the inverse twice, so it's not a function. When we do questions that ask us about where it's a function, do we draw in those vertical lines? Yes, you can. Or you can just write the vertical line test cuts the graph more than once. No, must. Okay, remember this is not a function, so you can't write f to the power of minus 1x. Okay, now the next question is actually what I will ask you in a test. Restrict the domain of f. In other words, restrict the x values of the blue one so that the inverse, the pink one, will also be a function. Okay, so now on the next page, there's only this. You have to draw and answer that question. Okay, if I cut my blue parabola in half at the turning point, is that still a function? Yes. If you draw this part's inverse, it will look like that. Is that a function? Yes. Yeah, okay. If I take the right hand side of the blue function, the parabola, and I draw that one's inverse, it will look like that. Is that a function? Yes. Yeah. So what you say is, if x is smaller or equal to the turning point's x, so smaller or equal to 0, or if x is larger or equal to 0, the right hand side of the parabola, then that restricts the domain of the blue one so that the inverse will be a function. Okay. But if I ask you to draw it, you do the following. So you draw two drawings. The first one is the half of the blue function and its inverse. It looks like a bird in flight. The other half of the function, other half of blue, and the other half of the pink look like a ballerina's two legs crossing, or her arms crossing. So these two look like that. You have to draw that in a test if I ask you to draw it. It's not in your notes. Page 9. And what's the answer? X must be smaller or equal to 0, or x must be larger or equal to 0. If I ask you to draw that, show me that it's like that, you have to draw it like this. Is it more often they ask to draw than to explain? Yeah. Okay. Why aren't you working? You're all looking at me. This is not in your notes. Or you can look at the video again and then draw it, but that won't happen. Okay, can I carry on? Remember, when you draw a graph and the inverse on the same axis, you have to draw the line of reflection y equals x. Yeah. Okay, can I carry on? Because I need to do 2 more examples. Then you can watch the video again and just draw your drawings. Okay? The next example, I ask you to determine the inverse of that parabola. It has a name fx. The first thing that I always do is I rewrite it as y equals. Then you do the inverse. So I swap the x and the y's. Factorize the right hand side. Get the square on both sides, square root. Remember, the square root on the left hand side is a plus or minus. Then take the minus 1 over to the other side, and that will be the inverse equation. But it's not f to the power of minus 1 because this is not a function. Then you get the turning point. First derivative set to 0, so that will be 2x minus 2 equals 0. Get x alone, so the turning point's x value will be 1. That you put in your table as the middle value. Go 2 to the left, 2 to the right, and calculate y. Show next to the table that the inverse, the y will be the x values and the x will be the y values. And then you draw your graph. Okay, so the orange graph, the turning point is at 1. And the green graph, the inverse, the turning point is also at y equals 1. Then I ask you, restrict the domain of f so that the inverse will be a function. So x must be larger or equal to the x value of the domain, 1, or x must be smaller or equal to the x value of the domain, 1. And your graphs look like that. Now, in this case, you can call this f minus 1 and this f minus 1 because they are functions.
So then basically when you restrict, you say that smaller than 2.4 big.
And if they want you to draw it, it should look like that. Okay. Look, you have to look at the number of marks that it counts. If it only counts 1 mark or 2 marks, you just write x larger or equal to 1 or x smaller or equal to 1. Yeah, original. Okay. The next question is determine the equation of the inverse by using completing the square. So I did mine a little bit easier than the one in your notes. You'll see some small differences. I put brackets around all the terms that have x's. And then I take the coefficient of x squared out of the bracket. But if you divide with that 2, you must remember you must divide here with a 2 as well. Okay. Now you have to add half of b squared and subtract half of b squared. Now I want the first 3 terms and I factorize that as a bracket squared. But this term must be multiplied with the coefficient in front of the bracket to be taken out of the bracket, and that you do on your calculator. Then you add plus 5 and you get your new formula in the turning point form. So now you can read off the x value of the turning point. What is that? Plus 3 over 4. Poppenjaar. Alright. To get the inverse, Manolo, you swap the x and the y, and then you get y alone as your subject. So this is the inverse of that parabola. In turning point form, inversed. Okay. Lekker toetsvraag. Okay, the question was, do it in turning point form.
Yeah, like when you see when y equals 2x squared minus, is that what we're doing? Yeah. And like if you just switch them around.
Okay, if you switch them there,
yes, then you change it to turning point.
Then you will also get that.
So you can start it from there.
Okay, but this, if they give you the form in this format, or the parabola in this format, how do you do the inverse? Like this. It's just an extra example to show you a different one. Now, your homework for tomorrow. And tomorrow I'm turning into a witch. Because no grade 12 learner did their homework. We did. Yes. For today.
Take the receipt.
For tomorrow, these up until exercise 3's number 1 to 3 must be done. Who did not do exercise 1? Who did not do exercise 2?
Is that it? But it's not. Really?